Hi, Assalamualaikum. Today, me and my friend from group 5B, we want to explaining to you about our experiment 5. Okay, the first one, let me introduce our group members. The first one is Nurul Najiha binti Muhammad Nizam. The second one is Nurul Alisa Afira binti Zainuddin. The third one is Hadiatul Husna binti Muhammad Halim. And the fourth one is me, Nur Amira Husna binti Nur Zaihan. And the last one is Sharifah Nur Ifah Najla binti Sheikh Shamsuddin. Okay. Hi guys, today I will be introducing you to gas chromatography, commonly known as GC. First, what is gas chromatography? It is an analytical technique used to separate and analyze compounds that can be vaporized without decomposition. This makes it especially useful for studying volatile organic compounds. The main purpose of GC is to identify, quantify, and purify individual components in a mixture, which is very important in fields like environmental science, food safety, and forensic analysis. As for the setup, GC consists of several key components. The carrier gas, which transports the sample, is an injector to introduce the sample into the system, a column where the separation of components happen, a detector which sends and records the presence of each compound, and a data system which helps us analyze the result. Finally, the advantage of GC include high sensitivity, excellent resolution, and rapid analysis time, making it one of the most powerful tools in modern analytics.
So, moving forward to the objectives, there are 4 objectives in this experiment. First, this experiment is conducted to determine the retention time for the sample using the chromatography machine. Second, we want to identify what compounds are present in the standard mixture by using the retention time. Next, we want to identify what compounds are present in the unknown. Last but not least, we want to identify how temperature can affect the values of retention time. Now, we are going to list down all the materials that we use. For the apparatus, we use one is ring, beaker, and dwarf. For the chemicals are used. The chemicals that we use are compound 2-propanol and butanol, the unknown sample, and also standard solution that consists of 2-propanol and butanol. These standard solutions are prepared using the 1:1 ratio.
Hi, Assalamualaikum. My name is Hadiatul Husna. So here is the methodology for gas chromatography. First, rinse the syringe before filling it with the sample, and then the volume of the sample may be more than the required volume. Make sure there are no air bubbles in the syringe. To remove air bubbles, gently tap the syringe, and then hold the syringe vertically, needle up, and push the plunger to the required volume at eye level. Lastly, remove the excess sample using the tissue.
Next is the experimental part. First, we switch on the gas chromatography instrument. Then we set the gas chromatography with this setting. After the settings are done, we inject each component sample one by one to find out their retention time. Next, we inject the standard mixture. We compare the retention times of the mixture with the single components to help us identify them. After that, we change the column temperature to 100 degrees Celsius and inject the standard mixture again. We observe how lowering the temperature affects the retention time and separation. Lastly, we increase the oven temperature to 140 degrees Celsius, inject the standard mixture again, and observe how higher temperature affects the retention time and separation. For the operation of the gas chromatography, I've already listed the steps clearly on the slide. Basically, we start by checking the instrument setting, the method, and choosing the right injection mode depending on the sample. After setting everything, we inject the sample quickly, press start, and analyze the result.
In this diagram, the diagram shows the flow of the sample in the gas chromatography. First, the sample will transfer from the carrier gas to the flow controller. Then, flow controller will control the pressure of the sample to go through the injector. The injector will then inject the sample in a column for separating process, while in the oven will control the temperature of the sample. After the sample completely separated, it goes to the detector. The detector will then identify the sample, then goes to the amplifier. The amplifier will then send the signal, goes to the chromatogram to analyze the sample to the data system. In the gas chromatography, there is a lot of mapping and lot of instruction. We start off with the carrier gas. Carrier gas will act as a mobile police, transporting the sample to the column for separation to start. Usually, the common gas for the carrier gas is helium, nitrogen, or oxygen. Then, the sample will go through the flow controller. Flow controller will function as to control the pressure of the fluid in the gas form. The flow controller will control the pressure into the desired level. Then the sample will go through the injector. The injector will introduce the sample to the system into the column. Then the column will separate the mixture component based on the different instruction with the stationary phase. Column is inside the oven, and the oven is also function for the host for the column. The oven also has the function to control the temperature for the separation of the sample. After the separation of the sample will go to the detector to identify and quantify the separated compound as the dilute on the column. And then the sample will go to the amplifier. Amplifier will enhance the weak electrical signal generated by the detector. And the last one is chromatogram. After the sample goes to the chromatogram, it will identify and measure the chemical compound in a sample for the data analysis.
Okay, for this slide shows the gas chromatography analysis result of propanol. On the left is the chromatogram, and on the right is the data table. We observe two peaks indicating two components in the sample. Peak 1 has a retention time of 2.22 minutes and represents 37% of the sample, while peak 2 at 2.47 minutes is the major compound with 63%. This result suggests the sample might be a mixture of isomers or impurities in propanol.
This is the result for butanol. The sample that we are tested is N-butanol, heat at 70 degrees Celsius using the gas chromatography. 3 peaks are observed from this experiment. Among all the 3 peaks, the highest peak was recorded at peak 3 with a retention time at 6.043 minutes and area percentage of 99.84%. You can check the retention time and the area percentage in the table below. This peak matches the examined compound, which confirms to be N-butanol. The rest of the peaks recorded at 2.926 and 2.659 minutes represent the impurities of this experiment. This is because both peaks have lower retention time and area percentage. Having lower retention time means impurities will flow faster to the stationary phase of the chromatography and out of the sample. Meanwhile, N-butanol will elute slower to the stationary phase.
Now I will explain the analysis of our standard mixture. Standard mixture, we use half propanol and half butanol with ratio 1:1. This standard mixture experiment conducted at 70 degrees Celsius. In this chromatogram, we observe three main peaks. Peak 1 corresponds to 2-propanol, peak 2 represents some impurities present in the mixture, peak 3 is identified as N-butanol. We can see from the data that 2-propanol elute first. This is because 2-propanol has a lower boiling point compared to N-butanol. As we know, compound with lower boiling point tends to elute faster in gas chromatography. Meanwhile, N-butanol having a higher boiling point elute later. This boiling point difference directly influence both the retention time and the peak area that we observe in the chromatogram. In summary, retention time is closely related to the volatility of the compounds, with more volatile compounds appearing earlier on the chromatogram.
We can see in the standard mixture at 100 degrees Celsius, the highest peak is peak 4, with the retention time is 3.294 and the percentage of 62.79%. The highest peak we can see is actually N-propanol, because N-propanol is eluted really quickly and readily available. N-propanol usually used for determining the alcohol component, and during 100 degrees Celsius, they return into gaseous state, which allow it to be separated and detected in the gas chromatography.
And for the last standard mixture that conducted at 140 degrees Celsius, we can clearly see the first peak that appeared at 1 minute and 65 seconds is a peak for butanol, and the peak appeared at 2 minutes 22 seconds is the peak for 2-propanol. This is happened because GC run maybe was done at a significantly higher column temperature or different setting.
So for this experiment, we can discuss that the length, temperature, gas flow rate and column condition can all affect the retention time, which is a measurement of how long a solid takes to move through a chromatography column. For substance, a normal combination of 2-propanol and N-butanol, an identified sample were examined in this examination at various temperatures. The standard combination displayed 2 peaks at 70 degrees Celsius, signifying the presence of 2 chemicals. Retention time decreased with higher temperature. It was determined by comparing retention period that both 2-propanol and N-butanol are present in the standard combination. It was determined that the unknown sample contained solely N-butanol, since one peak matched the retention duration of N-butanol.
So to conclude this gas chromatography experiment, the retention time of N-butanol and 2-propanol were recorded in the data table, and based on this value, the compound present in the standard mixture is identified as 2-propanol. The temperature of the column affect both the retention time and resolution, so when the column temperature decreased, the retention time increased and the resolution improved, while an increase in column temperature result in a shorter retention time and lower resolution.